Welcome, this is Professor Ridge, and today's lesson 2.2, linear equations in one variable. Our first learning objective is to solve equations in one variable algebraically. A linear equation in one variable can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. So the thing note here is in the definition, we have a lot of definitions, says, hey, this is something that can be written. Okay, so can be written. Doesn't say that it is written. So basically anything that you can use algebra to create an equivalent form to this will be considered a linear equation. And the big thing is that the degree is going to be degree 1 for the variable. So this is to the first power. That's the big thing. Okay, so I'd like to point out that a solution to an equation is a replacement value for the variable that makes the equation true. So example, if I had an equation 2x plus 3 equals 5 is 1 a solution? And the answer is yes, since 2 times 1 plus 3 equals 5 is a true statement. Okay, so 1 is a solution to that equation. We would say the equation has a solution. If 1 is the only solution, then the solution set would be just the set that contains 1. And then that brings me to my next point. So the solution set consists of all values that make the equation true. To solve means to find the solution set. So if you're asked to solve an equation, you're asked to find the solution set. Now just give you an example of the difference between saying to solve or is this a solution. Is 2 a solution to the equation x squared equals 4? And the answer is yes, comma, since 2 squared equals 4 is true. So 2 is a solution. But if I said solve the equation x squared equals 4, and you said, oh, 2 squared is 4 is true. So x equals 2 and you're done. And the answer is this is not correct. Why? Because to solve means to find the solution set. The solution set consists of all values that make it true. So the solution set, would be -2 and 2. Now I've solved the equation. So this would be correct. Okay, so 2 is the solution to the equation. -2 is the solution to the equation. To solve the equation, you got to state the solution set, which lists all of the solutions to the equation. We can classify linear equations in one variable as one of 3 types. You can have an identity, a conditional, or inconsistent. So an identity equation is true for all values of the variable. So here's an example, 3x equals 2x plus x. Now, no matter what I pick for x, this statement will be true. So if x is 5, for instance, you would get 15. So let's see. Let's let x equal 5. You get 15 equals 10 plus 5, which you can see is 15, which is true. If x is, say, -2, you would get 3 times -2 is -6. -2 times 2 is -4 plus -2. -6 equals -6. True. So you can see that no matter what you choose for x, both sides will always be the same. So the solution set will be the set of all real numbers. Okay, so the solution set is all real numbers. Okay. Now, conditional statement is true for only some values of the variable. So it's going to be sometimes true, sometimes false. So in this example, we have this equation, 5x plus 2 equals 3x minus 6. And then if you simplify both sides, actually, they're going to subtract 3x, subtract 2, and then divide both sides. We'll go over this in a little bit. So basically, the solution set consists of just one number, -4. So it's the only solution, and therefore we have solved the conditional equation. So again, you want to, for conditional statements, to solve it, you find the solution set. This is everything that makes it true. Everything else would make it false. Okay, and then the third type of equation is an inconsistent equation, which results in a false statement. So for example, if we solve this equation, 5x minus 15 equals 5 times quantity x minus 4, we have the following. So let's say if you simplify that side, 5x minus 20, you subtract 5x from both sides, so the 5x's cancel. And then we're left with a -15 and -20, which is clearly false. So no matter what you choose for x, this statement will never be true. So there's no solution that is inconsistent equation. So if you were to solve this equation, you would say has no solution, so the solution set is empty. Okay, so how to. Given a linear equation, one variable, using algebra to solve it. The following steps are used to manipulate an equation and isolate the unknown variable. So the last line reads x equals whatever the number is, if x is the unknown. There's no set order, as the steps used depend on what is given. All right, so this is kind of the outline. You can basically follow these rules. So you can add, subtract, multiply, divide an equation by number or an expression as long as you do it to both sides of the equal sign, right? Golden rule of algebra. No, the only thing you can't do is you cannot divide by 0. So that's not allowed. Okay, then you're going to apply the distributive property as needed. Isolate the variable on one side of the equation. When the variable is multiplied by a coefficient in the final stage, multiply both sides of the equation by the reciprocal. I actually think of it in a little different terms, and I'll show you. All right, let's look at example 1. I'll kind of go through the process that they do. I do it a little bit differently, but it's the same idea. We'll get you the same result. So typically I start by saying, can I simplify either side first? And if I can, I do it. That's usually my first step. So I kind of follow this order. I want to simplify the sides if possible. Two. Okay, once both sides are simplified, then I want to get all the variable terms on one side. Okay, so again, 2, I want to get all the variable terms on one side using the add subtract property. So here we only have 2x and there's no other variable terms, so that step 1 and 2 are done. There's nothing to do there. Okay, so step 3 now is on the side of the variable term. So you can see on the left side here of the equation, we have the 2x. We want to get rid of the constant term, the numbers, right? No variable, by using the add subtract property. So what we're going to do, there's a couple ways you can do this. We want to cancel this plus 7, so we're going to subtract 7. And then, like it said in the book's rules, whatever you can add, subtract, multiply, as long as you do it to both sides. So we got to subtract 7 from both sides. Now typically, I don't write it like this. Typically, when I do it, I just go minus 7 like that. And then on the left side, 2x plus 7 minus 7 is 2x. And on the right side, 19 minus 7 is 12. That's typically the way I show it. So either way, it's fine. Okay, now to the fourth step. So now the fourth steps, you're going to divide both sides by the coefficient of the variable term. So 2x is the variable term, so we're going to divide both sides by 2, which is the coefficient. And the reason we do that is we want to get x by itself. 2 divided by 2 is 1, and you just have x or 1x. Remember, 1x is the same thing as x. So this is technically the simplified form of 1x, but they're the same thing. And then 12 divided by 2 is 6. And then that is our solution. And since this is a linear equation, the solution set's just that one number. And basically, this is the steps I use to solve these. All right, let's look at example 2, and we'll follow steps that I outlined in the previous example. Okay, so my first step is I want to simplify both sides individually. So just look at the left side here, and we want to simplify it. So we're going to get rid of parentheses. 4 times 3 is 12. Okay, combine like terms. Minus 12 plus 12 is just 0, so those go away. Okay, so this side's simplified. Now we're going to simplify this side. Now we're going to distribute the negative 5. So you got 15 minus 5x. Negative 5 times positive 6 is negative 30. Combine like terms. So we got these constants that can combine. 15 minus 30 is negative 15. So we got negative 5x minus 15. All right, so that was step 1. Step 2 was we're going to get all the variable terms on one side using add, subtract. So we're going to get all the variable terms on one side. So I'm going to add 5x to both sides of the equation. So 4x plus 5x is 9x. Minus 5x plus 5x is 0. And then I got the minus 15. Okay, then step 3 is on the side of the variable term, get rid of the constant by add, subtract. Well, we have the variable term by itself. So on to step 4, which is we're going to divide both sides by the coefficient. So 9 divided by 9 is 1. X, which is x. And then this, let's see, 15 is 3 times 5. And the negative is negative 1. But anyway, 9 is 3 times 3. So I can cancel a 3. You get negative 5/3. So my solution set is negative 5/3. So I've solved the equation. Remember, I consider solving an equation when you find the solution set. So this is the way you do it. So you're not done until you say what the solution set is. Okay, on to the next objective. Solve a rational equation. Okay, solving a rational equation. So in this section, we look at a rational equation that, after some manipulation, results in a linear equation. So basically, they start out as a rational equation because they have a fraction in it, a rational expression. And then we're going to do some tricks to it, manipulate it, and then it's going to result in a linear equation. So that's why it's kind of stuck in this section here. But since it starts, the original equation starts out with a rational expression, so we call it a rational equation. All right, looking at example 3, solving this rational equation. 7 over 2x minus 5 over 3x equals 22 over 3. Now the technique is you're going to multiply both sides of the equation by the LCD of all the denominators. So we have 2x, 3x, and 3, the LCD, so looking at the numbers 2 and 3, that's going to get us 6, and then we just need one x. Okay, so if you forgot how to find the LCD, remember you factor it, and you take each factor the greatest number of times it happens in any one factorization. So 2 happened once, 0, 0, so I need 1, 2. 3 happened once, so I just need 1, 3, because it's the greatest number of times, not the total number of times. And then I need 1x, because I got 1x here, 1x here, 0x is here. So 6x my LCD. Okay, now we're going to multiply both sides of the equation by 6x. And I'm putting it over 1. And then what happens is you're going to distribute. So I'm going to do minus 6x over 1. And we're doing it to both sides. And then you can see, let's see, the x's cancel. Here, let me put it red here. So the x's cancel. 6 goes in, 2 goes into 6, leaves you a 3. Here the x's cancel. 3 goes in 6, leaves you 2. On this one, the 3 cancels 6 and leaves you a 2. So then we multiply what's left over. You get 21 minus 2 times 5 is 10. And then equals 2 times x times 22 is 44x. Now, you just got a simple linear equation. So we simplify 21 minus 10 is 11. We want to get all the variable terms together on one side. There's only one, so that's done. Get all the constants on the other side. That's done. And then divide both sides by the coefficient of the variable term. Now we're going to divide by 44. And we can reduce that fraction. And I'm going to flip it around. So x is equal to 1/4. Divide both by 11. So our solution set is 1/4. All right, let's look at example 4 here. So again, we're going to, our first steps, we want to clear the fractions, right? So we got to figure out the LCD. So we have x, 2, and 2x. And then our LCD, remember, let's start with the numbers. So there's just 2. And then x, we have 1x, so just 1x. That'll be our LCD. So we're going to multiply everything by 2x and distribute it. So I just like to go ahead and go 2 over x. 2x over 1 times 3 over 2. Okay, so now we're going to cancel. So the x's cancel. You're left with 4. I'll come back and write that in a minute. Here the 2's cancel. Here the 2x's cancel. Now if you do the right LCD, the denominator should all be 1. So basically the fractions go away. So we get 4. Here the 2's canceled. So you get 3x minus 3x. And here the 2x cancels and we're left with 7. Okay, so now we're left with a linear equation. So we're going to simplify the sides. They're simplified. Get all the variable terms on one side. That's done. Get the constant terms on the other. So I'm going to subtract 4 from both sides. So I have the variable terms on one side, the constants on the other. Then the last step is you want to get x by itself. So divide by the coefficient of x, or your variable, whatever the variable is. So here -3 cancels. I get x by itself. See, I isolated the variable. And 3 divided by -3 is -1. And my solution set's -1. Oh, before I do this, I guess you got to remember that the original problem, anything that makes the denominator 0, you're not allowed to use it. So you have to check before you say this, that this solution doesn't result a 0 in any denominator. So we just got to make sure that we're allowed to use it, which obviously, well, maybe not so obvious, but it works because, right, none of the only thing we got to worry about, you can check it, you can type this in calculator, make sure they're equal. But what we're looking for is anything that's 0 on the bottom. You can't use it and you would have to throw it out. Okay, so you have to verify that you're allowed to use it. So the only number you wouldn't be allowed to use is if x was 0, it would make this 0. And same thing here. If x is 0, it would make that 0. So 0 is not allowed. Okay, let's look at example 5 here. So our LCD, we have x. We have 10, which is 2 times 5. And we have 4x, which is 2 times 2 times x. So our LCD, we'll do the numbers first. I have 1, 2, 2 2s. So the greatest number of 2's in any one of the factorizations is 2 2's, right? I got 0, 1, 2. Now for 5, I got 0 5's, 1 5, 0 5's. So I need 1 5. X's, I got 1, 1. So I need 1x. So then my LCD would be 20x. So I'm going to multiply everything by 20x. Oops. Okay. I was going too fast. 20x over 1. All right, so now let's do my canceling. So here, just the x's cancel. So we're left with 20. Here, let's see, 10 goes into 20, leaves you a 2. You have 2x. 4x goes into 20x, leaves you 5. So the x's cancel. 20 divided by 4 is 5. So, and then what we're left with, 3 times 5 is 15. All right, now we got this linear equation. Simplify both sides. That's simplified. We want to get all the variable terms on one side, which it is. Now get the constants together on the other side. So I'm going to add 15. So remember, my goal is to get x all by itself on one side. So 20 plus 15 is 35. The 15's cancel. We just left with 2x. Then the last step is you want to get x by itself. So divide by 2. We get x equals 35 halves. And then that's my solution set. And again, we got to identify, before we actually go on, we make sure that this is allowed. And the only thing that you've got to exclude would be 0 or 0. 0. So this is fine. All right, let's look at 6 here. So for A, our LCD will be, now when you have binomials, you want to think of that as one number. So for my LCD, the denominator for this is x minus 6. Think of that as one number. And then x is a different number. So the LCD is going to be, I need 1 x minus 6, and I need 1 x. So typically I write the x in front. So I'm going to multiply both sides by x times x minus 6. Okay, do my canceling. X minus 6 cancels x minus 6. We're left with 3x. The x's cancel. We're left with 5x minus 6. The quantity x minus 6. Okay, so now we got a linear equation. And note, note, x is not allowed to be 0 or positive 6, because then 6 minus 6 is 0, which would make this undefined, and 0 would make this one undefined. So these two numbers, if I get a solution, this is what I was saying earlier, if my solution is either of these two numbers, I have to throw it out. Can't use it. So these numbers are not allowed to be used. Alright, so simplify the sides, so I can simplify the right side. I can distribute the 5. Now I want to get all my variable terms together on one side. So I subtract 5x, so that's 2x, negative 2x. And I want to get all the constants on the other side, which there already are. So I can skip that step. Then I want to divide by the coefficient to get x by itself. So then we get x equals 30 divided by 2 is 15. Negative and negative make positive. So my solution's 15. And see, 15's allowed because these two are not allowed. Everything else is okay. So that will be my solution set. All right, let's try B. Okay, so x over x minus 3, 5x minus 3. So my LCD is going to be, I need an x minus 3 and a 2. So it's 2x minus 3. So I'm going to multiply everything by that LCD. And I got to distribute it, so it's going to be to both things. Alright, so let's start with my canceling. The x minus 3's cancel. You're left with 2x. Over here, the x minus 3's cancel. So I'm left with 10. 2 times 5. Here, the 2's cancel. Now be careful with this minus. So you got to just, so minus 1 times x minus 3, you got to distribute it. So then that will get us negative x plus 3. So be careful. All right. So again, we're left with a linear equation. And note again, just to kind of point out, x cannot equal positive 3 because that would make this 0. All right. So simplify both sides. So this side's simplified. 10 plus 3 is 13. We want to get all the variables on the same side, so add x. Once you get a little practice, you don't have to show plus x, just in your head. Do it. Get all the variables on one side, we did. And then we got constants on the other, they are. So that's done. And then just divide by the coefficient to get x by itself. Verify that you're allowed to use the answer. Right? We can't use 3, this 13/3, which is fine. If you want to check it, you can plug it in and see that it works. And I'll leave that for you to do. So typically I always check, but I'm not going to right now. Alright, let's look at C now. X over x minus 2. 5 over x minus 2 minus 1/2. So our LCD will be 2 and x minus 2. Okay, and with a little practice, this is what I do. So just kind of, I visualize in my head. Okay, I got the x minus 2's cancel. All right, so the x minus 2's cancel. And I'm left with 2. I'm left with the 2 and the x. And here the x minus 2's cancel. So I'm left with the 5 times the 2, which is 10. And then on this one, the 2's cancel. And I'm left with the negative 1, x minus 2. So that'd be negative x plus 2. Now be careful. So basically the same idea. There's not much difference between B and C here. Just x minus 2 instead of x minus 3. But anyway, so let's see. I'm going to combine like terms, simplify the sides. Then I'm going to add x, get all the variables on one side, and then divide by the 3. So x is 4. We can note that for our domain, x cannot equal 2. Our solution's 4, so that one's fine. So our solution set's just the number 4. All right, let's look at example 7. So we got 2 over x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. So my first step is I'm going to factor that denominator. I'm going to go ahead and leave room for my LCD. Okay, this is different squares, so it's x plus 1 times x minus 1. Now my LCD, looking at the factored form, my LCD, how many x plus 1's do I need? I got 1 here, 0 here, 1 here. So I just need 1 x plus 1. X minus 1's 0, 1, 1. So remember, it's the greatest number of times it happens in one factorization, not total. Just the most times it happens in one factorization. Okay, so I'm going to multiply everything by the LCD on both sides. It gets distributed. So it turns out you multiply every term by the LCD. We do our canceling. So again, with a little practice, I don't ever write this step. I write, here's my LCD. I'm multiplying it. I'm canceling the x plus 1's. I'm left with 2 times x minus 1. Minus 1. The x minus 1's cancel. X plus 1. And here both of them cancel. So I'm left with just the 2x. Okay, and again, I got a linear equation. So we're going to simplify it. Distribute that 2. Distribute the negative 1. Okay, 2x minus 1x is x, or 1x. Same thing. Negative 2 minus 1 is negative 3. Okay, get all my x terms on one side. 2x minus 1x is x, or 1x. And then we're done. So let's see, what things am I not allowed to use? See, they want to state the excluded values. So x cannot equal. This will be negative 1, and then this one be positive 1. So we're fine with the negative 3. That's our solution set. All right, on to the next learning objective. Find a linear equation. Okay, so we have slope-intercept form, right? Y equals mx plus b, where m is slope and b is the y-intercept. So the slope of the line is given by this definition. The slope of the line m represents the change in y over the change in x, given 2 points x sub 1, y sub 1. So that's point 1. Point 2, x sub 2, y sub 2. The following formula determines the slope of the line containing these points. So we're going to do the difference in the y coordinates over the difference of the x coordinates. And the order matters on this one. So if we're going to call one of them point 1, the other one point 2, you want to be consistent. You're going to do y2 minus y1 over x2 minus x1. Now you can switch it as long as you switch both of them. Okay, I'm not going to write that down though. Okay, let's look at example 8 here. So we want to find the slope. So we're going to use this formula, y2 minus y1 over x2 minus x1. Given these 2 points, so this is point 1, this is point 2. So we're going to subtract y2 minus y1. So it's 3 minus a minus 1 over x2, which is negative 5, minus x1, which is 2. So 3 minus a minus 1 is 4. Negative 5 minus 2 is negative 7. So our slope is 4/7. Or should I say negative 4/7, right? So bring this negative out in front. Same thing. So 4 over negative 7, negative 4 over 7, or negative 4/7. They're all the same thing, right? So negative a over b, a over negative b, is negative a over b. So that negative, you can put it in any of the places. Okay, positive divided by negative. Positive divided by negative, negative divided by a positive is the same thing as a negative, the two numbers divided by. Example 9, identify the slope and y-intercept of a given line. So again, we identified that this is slope-intercept form. So y equals mx plus b is slope-intercept form. Of a line where slope is equal to m and the y-intercept. Now remember, y-intercept, the x-coordinate is 0, and then the y-coordinate, if you put in 0 in here, doesn't matter what m is, anything times 0 is 0. And then y is going to be b. So if x is 0, y is b. So you don't really have any work to do. You can read it off. So this makes this problem super easy. The slope, that's your m, slope. So it's negative 3/4. And then our y-intercept is going to be 0. Then if you put in 0 here, that goes away. This is going to be your b, which is the y-coordinate of the y-intercept. So it'll be negative 4. All right, and that's it. Simple as that. Okay, an alternate form for a line is the point-slope formula. Given one point and the slope, the point-slope formula will lead to the equation of the line. So the point was the x1, y1. They should have wrote that in there, x1, y1. So if you're given one point, you're going to plug in the point x1, y1, and given a slope, m, right? So you're given the slope, m, given a point, you just plug it into this formula. So let's look at example 10. So if I do y minus y1 equals m, x minus x1, we're given the slope is m is negative 3. M is negative 3, and it passes through the point 4, 8. So x sub 1 is 4, and y sub 1 is 8. And notice how this is 4, 8. In the formula, it's minus. So it'll be minus positive 4. So it'll be minus 4 and minus 8. Okay, so if now I'm going to convert it to slope-intercept form. So I'm going to distribute the negative 3. So it'll be negative 3x plus 12. And then I'm going to add 8 to both sides. So y equals negative 3x plus 20. Okay, so that's a really nice form of the line. If you're given a point and a slope, you're going to use the point-slope formula. Technically, you could still, sometimes I just use the slope-intercept formula. Here, let me show you. So I start out with y equals mx plus b. I'm given the m is negative 3, and I'm given a point on the line, so that's an x and a y. So I plug it in for the x and the y. And now I'm going to solve it for b. So this is the other way to do it. So when I solve it for b, you get b is 20, right? You can see that's 20 over here. And then now I know the slope, they gave it to me, m, and I know the b, I figured it out. So y equals negative 3x plus 20. So whichever way makes most sense to you, do it that way. Be nice if you know both ways, but whichever way. I don't care. All right, moving on to example 11. Find the equation of the line passing through the 2 points, 3, 4, 0, negative 3. Write the equation in slope-intercept form. All right, so to write an equation in slope-intercept form, remember we need to know 2 things. We need to find the m and find the b. So find m and find b. So they give you 2 points. We have what's the slope formula. Using the slope formula, given 2 points, y2 minus y1 over x2 minus x1. So I'm going to go negative 3 minus 4, 0 minus 3. So I got negative 7 over negative 3. So the negatives cancel. So it's 7/3. Now, at this stage, I can do it just like the previous example. I can do it either method that I showed you. Let's just use the point-slope form. So y minus y1 equals m x minus x sub 1. So I'm going to use this as my point 1. Oh, you know what? Actually, this is my y-intercept. So this would be b. So I'm not going to do it this way. I'm done, right? Y equals m, which is 7/3, x. So sometimes it helps to pay attention. Right? Let me go ahead and do it this way, like I didn't realize that was it. So let me just go ahead and do it. Okay, so let's pretend I didn't recognize that. So y minus y1 would be 4. M with 7/3. X minus x1 is 3. So I'm going to distribute the 7/3. So 7, that's 21 over 3. Well, the 3's would cancel. So it'll be negative 7. Then I'm going to add 4 to both sides. And you can see I get the same answer. Okay, so you do it either way. Now, the third way to represent a line, we got the standard form of a line. So we can represent a line in what's called standard form is given by ax plus by equals c. A, b, and c are integers, and x and y terms are on one side. The constant term is the other side. And some books, too, they like a to be a positive number. So that'd be another condition. That's not required. But notice they have to be integers. So you want to get rid of any fractions. Okay, let's look at example 12. Find the equation of the line with slope -6, passing through the point 1/4 -2. Write the equation in standard form. Okay, so let's first use slope for point form. Since we got a slope and a point, we'll do point slope form. So y minus y1, which is -2. M is -6. X minus 1/4. So we got y plus 2 equals -6x plus 6/4, which reduces to 3/2. Okay, we're going to, let's see, we're going to add 2. No, sorry. We're going to subtract 2. And we get y equals -6x. So let's see, this will be 4/2. So 3/2 minus 4/2. 3/2 minus 4/2. 2 is 4/2. Would be -1/2. Okay, so that's slope-intercept form, but we want it in standard form. So we need to add 6x to the other side. So we get 6x, and then this is plus y, equals -1/2. And we want all these to be integers, so we need to multiply everything by 2. So now we're going to multiply everything by 2. So we get 12x plus 2y equals -1. And that will be our standard form for the line. Okay, on to the next learning objective. Given the equations of two lines, determine whether the graphs are parallel or perpendicular. Okay, so recall that parallel lines have the same slope, different y-intercepts, so they'll never intersect. And if they're perpendicular, they intersect to form a 90-degree angle. So if you look at the slopes of perpendicular lines, the slope of one line is the negative reciprocal other. So you can also define it as the product of the two slopes is -1. So if you take slope 1 and slope of line 2 and multiply them, you'll get -1. Okay, so for instance, if let's say you had a slope that's like this, and that slope is, say, I don't know, 2. It's not to scale here. And then if I wanted to do, so we'll call that M1, and then if I did the perpendicular line, M2, I'm going to do the negative reciprocal, so -1/2. Now if you do M1 times M2, you get 2 times -1/2. You get -1. Okay? So that's how you can do it if you just look at the slopes without actually graphing it. Okay, so graph the equations in given lines, state whether they're parallel, perpendicular, or neither. So what I'm going to do is put them both in slope-intercept form. So we get 3y equals -4x plus 3. We're going to divide. I want to get y by itself to be in slope-intercept form. Okay, so my slope is -4/3, and my y-intercept is 0, 1. Okay, that's for line 1. Now line 2, I'm going to do the same thing. I want to get y by itself, so subtract 3x. So subtract 3x, then divide by -4. So we get y equals negative make positive. And then 8 divided by -4 is -2. So my M2 is 3/4. And my y-intercept for line 2 is 0, -2. Now we're going to graph it. Alright, so for line 1, here's a review for if you forgot how to graph using slope-intercept form. You always start with the y-intercept. So we're going to start at 0, 1 for the first line. And you're going to count slope. Remember, slope is, I'm going to use delta, change in y over change of x, which we say is rise over run. So -4, when we say rise, it could also be going down if it's negative. So you're going to go down 4, then run, that's to the x. So we go down, right. Positive is right for x. 1, 2, 3, 4, -4, right 3. We can do it again. Or if I switch these signs, I can go up 4. That'll get me to 5, and then left 3. Then I can draw my line through it. Actually, I missed that spot. Let's see if I can fix it. Let me try that again. Okay, so there's my line 1. Okay, that's line 1. That's the, I'll just put L sub 1, line 1. Okay, line 2. My y-intercept's -2, 0, -2. So I start there. And I'm going to count rise over run 3/4. So I'm going to go up, right. Now I can change both signs. So let's see, up, 1, 2, 3, right 4. Do it again, up 1, 2, 3, right 4. It's off the chart here. Or I can go the other direction, go down 3, left 4. Make my graph. And you can kind of see that that makes a 90-degree angle. But, you know, we can't just eyeball it. It could be close. How do we know for sure that it's perpendicular? That's the rule. If you multiply if the slopes are equal, then it's parallel. If M1 times M2 equals -1, then it's perpendicular. Okay, so this one is, let's just verify. We got -4/3 times 3/4, which equals -1. Check. So their line 1 is perpendicular to line 2. Okay, on to the last learning objective. Write the equation of a line parallel or perpendicular to the given line, to a given line. Given an equation for a line, write the equation of a line parallel or perpendicular. So first, find the slope of the given line. The easiest way to do this, put it in slope-intercept form, okay? Then, use the slope and given point of the point-slope formula, or with the point-slope formula, and then convert it to slope-intercept form and compare the equation to the given line. Alright, so write the equation of the line parallel to this line, 5x plus 3y equals 1, and it passes through the point 3, 5. So our first step is find the slope of the given line. So we're going to put this in slope-intercept form. So subtract 5x from both sides. These are not like terms, so you just write them down. 5x plus 1, and then divide by the 3. So then we get y equals -5/3 x plus 1/3. So my slope is -5/3. Now, what we want is the parallel line, and we just talked about parallel lines have the same slope. So our parallel line, I'm going to put these two straight lines, it means parallel, not 11. My parallel line is going to be equal to my slope, which is -5/3. Okay, and then it's passing through the point 3, 5. So I'm going to use my point slope form. Plug in the given point and the slope we just figured out. So x minus x1 is 3. Y minus y1 is 5. Then convert it to slope-intercept form. So distribute the negative 5/3. Negative, negative make positive. The 3's cancel. Then I'm going to add 5. So y equals negative 5/3 x plus 10. That is my answer. All right, looking at 16 here. Find the equation of the line perpendicular to 5x minus 3y plus 4 equals 0 and passing through the point negative 4, 1. Okay, so my first step is I'm going to put this in slope-intercept form. So I'm going to subtract 5x. Actually, I'm just going to add 3y because I want to get y by itself. So, and then I'm going to switch it around. So 3y equals 5x plus 4. And then divide by 3. So you divide everything by 3. Okay, so my slope is 5/3. So then my perpendicular slope, remember, it's negative reciprocal. So you just flip this over and change the sign. So it'll be negative 3/5. Okay, so now I'm going to use the point that was given. So y minus y1 equals, I'm going to put in my perpendicular slope. X minus x1. So y minus, oh, this upside down t means perpendicular, right? Y minus y1. Y1 is 1. My perpendicular slope is negative 3/5. This is perpendicular to the original line. And then x minus x sub 1 is negative 4. So that becomes plus 4. Okay, distribute. So negative 3/5 x minus 12/5. Then we're going to add 1. Add 1. Remember, 1 is 5/5. So 5/5. So negative 12 plus 1, which is 5/5, be negative 7/5. And that's my final answer there. Box that. Okay, that brings us to the end of the lesson. So make sure to practice all the exercises at the end of the set of the section. All right, and see you next time.